Welcome to National 4-5 Chemistry. This set of videos is all on rates of reaction, and we're going to start off by looking firstly at chemical reactions in general and identifying the signs of a chemical reaction. So our learning intention is to revise what the signs of a chemical reaction are from S1, S2 and S3. So hopefully be able to identify a chemical reaction by a change in appearance, by a detectable energy change, or by gas or solid being formed. Understand that all chemical reactions involve the formation of one or more new substances, and be able to give everyday examples of chemical reactions. So firstly, what is a chemical reaction? Well, a chemical reaction is a change that takes place when one or more substances, which we call reactants, react to form one or more new substances called products. And the general form, if we were to describe a chemical reaction, is reactants arrow, and that arrow means a transformation into product. So reactants always on the left-hand side of the arrow, and products always on the right-hand side of the arrow. So for example, carbon plus oxygen going to carbon dioxide. You can see that we have two reactants and we have one product. Where we have more than one reactant, what we use to separate them is a plus sign. If we had more than one product, we would also use a plus sign. So it's kind of written like a maths problem. However, in chemistry, remember that there's always an arrow goes between reactants and products. Do not put an equal sign. Now, in a chemical reaction, you always get one or more new substances formed from the reactant. So there is a complete transformation and you make something new. The starting substances are the reactants, the new substances are the products. And the arrow means changed into or transformed. And one reason we use an arrow is also to describe the fact that in many cases, it is very difficult to reverse the chemical reaction. It can only go in one direction, and that arrow shows us the direction in which that chemical reaction occurs. Now, chemical reactions are happening all around us every day. All living things are, in essence, bags of chemical reactions that are constantly happening. That's what life is. Chemical reactions happening in a logical order. And what we need to be able to do is to identify some chemical reactions. Now, what we're going to see on the next few slides are some everyday chemical reactions or examples where chemical reactions are happening. So the first one is making toast. You cannot untoast toast. Once the bread has been toasted, you could maybe scrape off the toasted parts. However, those toasted parts cannot be untoasted. So that is a chemical reaction. The next thing is eating the toast. So whenever we eat food, our bodies do chemical reactions to the food in order to break it down and transform it into new materials that we can get energy from. So this one is a plant growing, and you can see that throughout the life cycle of this plant as it grows, it's constantly transforming and making new things, and that is because it is doing chemical reactions. These are all forms of transport, and in every single one of these forms of transport, fuel is being burnt, and the fuel is being transformed into energy and into gases that come out of the exhaust of these different vehicles. So mobile phones, here's a really modern looking array of mobile phones, I'm sure you'll agree. But these mobile phones, where the chemical reaction is happening is in the battery. So what's happening whenever you charge your battery and whenever a battery is running and powering your phone, a chemical reaction is happening inside the battery. So that is where the chemical reaction is. Here we have a milk bottle that looks like it's been left outside for a very long time, and the milk going sour. You can see the milk turns lumpy. I imagine it's going to smell very bad. You cannot turn that sour milk back into fresh milk that is drinkable. Here we have an example of a reaction that happens to metals. In particular, we've got copper roofs oxidizing. Also iron will oxidize and it will rust. And you see a color change happening. With copper, it turns green. So for example, in case you didn't know, the Statue of Liberty looks green now, but when the Statue of Liberty was built, it was the color of that building on the left-hand side. It has oxidized over time to make it its current color. So how can you spot a chemical reaction? Well, chemical reactions can all look very different in appearance, but there are some common signs that you can look for to determine whether a chemical reaction has occurred. So here are some of those signs. So the first one is a color change. It's a very common sign of a chemical reaction. If you do a chemical reaction and the reactants are red and you do a reaction and now it's blue, that's a sign that something has happened. A precipitate forming. So a precipitate forming, what that means is if you mix two solutions together and from those two solutions you get a solid forming, that's a sign of a chemical reaction. And that's what's happening in the milk going off. That's why the milk gets lumpy and the solid is forming. That's what we would call a precipitate. We can also get an energy change. So one way in which the energy can change is that the reaction, you can feel it getting hot, you can feel it getting cold. You might also see an energy change in that the reaction might start to glow and give off light. That's another energy change. And finally, you could have a gas being given off. So you might see bubbles or fizzing in your reaction, or you might be able to smell something happening. So if a smell is given off, that's another sign of a chemical reaction. Now we're going to focus specifically on the change of energy, and we're going to look at what happens when a reaction gives out energy, it gets hot, or whenever it cools down. So when a reaction becomes hot and produces heat, that is it giving energy out to its surroundings. So if a reaction becomes hot, that heat energy is going into the surroundings. We call this type of reaction an exothermic reaction. Exo means outside and thermic means heat. So it is giving heat to the outside. So if a reaction heats up, it is called exothermic. When a reaction becomes colder, it's taking energy from the surroundings and putting it into itself. So it's absorbing heat from the surroundings. So it's taking heat in. Hopefully you can see between those two diagrams the word heat in the top one, the red one, is moving away from the beaker, whereas in the bottom diagram the word heat is coming into the beaker. Whenever a reaction is getting cold, it's absorbing heat from its surroundings, that is called endothermic. And endo means sort of inside. So that means the heat is going inside. So if a reaction heats up, it is called exothermic. If a reaction cools down, it is called endothermic. Those are two new words for National 4-5 that you probably didn't look at in S3. So really try and remember those two words. Exo for heating up, exothermic for heating up, endothermic for cooling down. So we're just going to summarize. Hopefully at this stage you can identify a chemical reaction by a change in its appearance. You could identify a chemical reaction by a change in energy, a gas being given off, or a solid being formed. You can hopefully state that all chemical reactions involve the formation of one or more new substances, and be able to give an example or a couple of examples of chemical reactions happening in our day-to-day lives. What's going to follow is a series of questions. So if you're watching along, what you can do is, if you need thinking time, you can pause the video to give yourself time to think. You might want to write down the answers, or you can just keep the answer in your head. Okay, it's going to be a few questions. So the first one, explain what is meant by a chemical reaction. So as I said, if you want to pause the video and write something down, do so. I'll just pause a moment on the video to let you answer. Well, a chemical reaction is when two or more substances react together to form a new substance. Remember the words you're going to want to use: reactants turning into products. So we just fill in the blank here. Two or more substances that react together are called. Two or more substances that react together are called reactants. The new substance or substances that form as a result of a chemical reaction, they are called the products, or if there's only one, the product. So this is your opportunity to write a list of signs of a chemical reaction. So list as many signs as you can. So the signs of a chemical reaction, if you're joining us after having paused the video, signs of a chemical reaction, things like color change, a precipitate forming, that means a solid forming, energy being released, so that could be light, it could be getting hot, it could be getting cold, an odor or a smell being noticed, bubbling or fizzing, and you might also notice light or sound being produced. So for this one, give 3 examples of everyday chemical reactions. So 3 everyday examples of chemical reactions. So what we have put are things like frying an egg, charging a phone, burning toast. You could have other things like burning fuel. You could say eating, plants growing. You could say frying an egg's already there. Any of those things, so rusting, anything like that is an everyday example of a chemical reaction. If a chemical reaction gives out heat energy, what word would be used to describe that type of reaction? So if a reaction gives out heat, what type of reaction is it? Well, that one is an exothermic reaction. So the final question is, if a reaction takes in heat energy, what type of reaction is it? So this time, if the reaction takes in heat energy, what type of reaction is it? Well, the answer is an endothermic reaction. So that's the opposite of an exothermic reaction. So that concludes our lesson on the science of chemical reactions. I will catch you next time when we move on to more about rates of reaction.